Okay, guys, so here's this one. So the graph of the continuous function g, the derivative of the function f is shown above. The function g is piecewise linear for -5 to 3. What they're telling you there is that all of its parts, like its pieces, are all lines, so it's piecewise linear. And then, um, the function is the same as g of x equals this for 3 to 6, okay, from there on. So A and B we don't know how to do yet, but we will soon. C and D we can do. Now guys, if you're given like that a graph is the derivative of another, or like a table is values of the derivative of another, or something like that, indicate that to yourself. So that's the graph of f prime. So this is just Susan's table stuff for C and D. So for -5 to 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. So f increasing would mean f prime positive, and concave up would mean f double prime positive. Actually, you know what? I'm going to say this. Okay, it does mean f double prime positive, that's true, but we're looking at the graph of f prime. So our explanation is gonna need to come back to the graph of f prime. So concave up, if you look on Susan's table, would be f prime increasing. So we're looking for where f prime is positive and increasing. Okay, so let me find where it's increasing. Okay, so it's increasing here, here, and there. Okay, so it's increasing, f prime is increasing on those pink intervals, but it is increasing and positive only on these pink and yellow intervals. Okay, so the answer is, for part C, the answer is from 0 to 1 union, from 4 to 6. Ooh, be careful because you don't want to say infinity. I almost said infinity, but look at this. They're asking about on this interval. Okay, so 0 to 1 and 4 to 6. Now the reason needs to say because something about f prime, because that's where we were getting our information. Because g, which is equal to f prime, is greater than 0 and increasing and increasing. Okay, so there's that. Okay, now for D, find the x-coordinate of each point of inflection on the graph of f. Give a reason for your answer. Guys, a point of inflection on the graph of f, that's going to be extrema on f prime. Okay, extrema on f prime. So if you look at this picture, there's only one place where we have an extrema, and it's right here. Okay, it's right there. None of these other, like, endpoint things, those are not extrema, because an extrema has to go from, the graph has to go from decreasing to increasing, or vice versa. Okay, there needs to be a change from increasing to decreasing, or vice versa. And this is the only place where that's happening. So x equals 4. Okay, and then I can say because f prime has an extrema there. Because f prime has an extrema there. Okay,